Redis is single-threaded, one thread, and it handles more requests per second than your entire multi-threaded backend. That sentence should bother you, because everything you were taught says it's backwards. More threads, more throughput, right? Here's how most of us met Redis. The database got slow, someone said, just cache it. You bolted Redis on, latency dropped, and you never thought about it again. In your head, Redis is a fast little box of key-value pairs that forgets everything when the power blips. But if that's all it is, why is it running message queues, real-time leaderboards? Why do some companies use it as their primary database? Calling Redis just a cache is like calling a phone a thing that rings. Technically true, misses everything. Next 8 minutes, why Redis is fast, and it's not the reason you think. Why one thread beats many, and the operating system magic trick that lets an in-memory database survive a power cut. First question, why is Redis faster than your database at all? When you query a relational database, it earns its latency. Parse the SQL, plan the execution, walk a B tree, and then, the expensive part, touch disk. Even the fastest NVMe SSD costs you tens of microseconds per access at best, and real workloads usually pay more. Redis refuses to pay that bill. It's an in-memory data structure store. Reads and writes never touch disk. Everything happens in RAM, where access time is measured in nanoseconds. That's not faster, that's a different unit. But hold on, if keep it in RAM were the whole trick, you wouldn't need Redis. A global variable in your Node or Python process lives in RAM too. So what's actually different? The answer is hiding in the name, not in-memory store, in-memory data structure store. Most caches understand exactly one thing, strings. Key in, blob out. So when you need to change one field inside a cached JSON object, look at what you actually do. Fetch the entire blob, parse it, edit one field, stringent it, write the whole thing back. 5 steps for one field. Redis doesn't store blobs. It stores shapes, lists, sets, hashes, sorted sets, each with its own commands, so you change the data in place, inside Redis, without dragging it through your app and back. Here's where that gets unfair. Say you're building a live leaderboard. In a normal database, every page load means resorting every row by score. Millions of rows, sorted from scratch on every refresh. In Redis, sorted set. Under the hood, it's 2 structures working together, a hash table and a skip list, and it keeps itself sorted on every insert. So when you ask for the top 10, there's no sorting left to do. It happened already, incrementally, on the way in. Read that again. The database did the computation before you asked. You're not storing data anymore. You're moving work out of your application and into the memory layer itself. Now the claim from the cold open. 10,000 clients hit your API. Your API hits Redis, and Redis answers all of them with one thread. No thread pool, no thread per connection. How is that not suicide? Flip the question. What actually makes multi-threaded systems slow? The moment 2 threads touch the same memory, you need locks. Thread A grabs the lock, thread B stands there waiting, and the CPU burns cycles just juggling threads and tracking who owns what. Threads don't just do work, they cost work. Redis noticed something sneaky. With all data in RAM, touching a value takes almost no time. The bottleneck was never the computation. It's the waiting. Packets crawling across the network. So Redis attacks the waiting. The technique is called I/O multiplexing. On Linux, it's the EE-poll system call. One thread watches thousands of connections simultaneously. A socket has a command ready, queued, executed, next. And because one thread executes everything, commands run strictly one at a time, which sounds like a limitation until you realize what it buys you. Atomicity, for free. 2 users decrement the same inventory counter at the same millisecond. One finishes completely before the other starts. No locks, no race conditions. Not handled carefully, structurally impossible. Fine print. Modern Redis can spin up extra threads, but only to read and write sockets and parse the protocol. Network chores. The part that touches your data still runs on that one lock-free thread, on purpose. So, blazing fast, lock-free, all in RAM. Which leaves one giant problem sitting in the room. RAM is volatile. Power cut, process crash, everything's gone. Instantly. For a throwaway cache, who cares? A miss just means asking the real database again. But sessions, shopping carts, anything you'd get paged for at 3 a.m.? It all vanishes on reboot is not a persistent strategy. Redis's answer isn't one mechanism, it's two, built on completely opposite philosophies. Mechanism 1, RDB, Redis Database. Point-in-time snapshot of everything in memory, written to disk as one compact file. Wait, Redis is single-threaded. Writing gigabytes to disk takes seconds. Does the entire database just freeze mid-snapshot? It would. And here's the trick that saves it. When it's snapshot time, Redis asks the kernel for a fork. Now there's a child process that, at that exact instant, points at the same memory as the parent. The child starts calmly writing that memory to disk. The parent keeps serving traffic like nothing happened. But wait, what if the parent changes memory the child hasn't saved yet? Copy on write. The moment the parent touches a page, the OS silently duplicates just that one page and hands the parent the copy. The child never notices. It keeps seeing memory frozen exactly as it was at the millisecond of the fork. Main thread, never blocked. Snapshot, perfect. Redis didn't solve this problem. It got the operating system to solve it. Mechanism 2 is the opposite bet. RDB snapshots every few minutes. AOF, append-only file, logs continuously. Every single write command that hits Redis gets appended to a file on disk as it happens. Crash? Recovery is beautiful in its stupidity. Read the file top to bottom, replay every command in order, arrive at exactly where you were. Production runs both. RDB for fast restarts and compact backups. AOF so a power cut costs you seconds of writes, not minutes. Stack it up. In memory, native data structures, one lock-free thread, persistence humming underneath. Now, just a cache sounds ridiculous. This is a Swiss Army knife for distributed systems problems. Rate limit an API? A Redis string with an expiration timer. Done. Pass events between microservices? PubSub or Redis streams. Stop two people from booking the same seat in the same instant? Atomic operations. The single thread guarantees it. No locking code required. Redis makes you think differently about where data lives and where work happens. Not rigid tables on a slow disk, but raw data structures at RAM speed, wrapped in a network protocol. So, the next time you type Docker run Redis, you're not spinning up a bucket for cache misses. You're spinning up one of the most elegantly engineered pieces of software in your entire stack. And now you know exactly why. If this finally made Redis click, drop a like and subscribe, and tell me in the comments which technology I should tear open next.